Hello and welcome back to Math 121. This is a video over section 1.6, and we're going to be talking about other types of equations. So we have we've been solving quadratics, but we're going to solve some more polynomial equations by factoring. We're going to solve radical equations. We're going to solve equations with rational exponents. We're going to solve equations that are in quadratic form, okay? And we're going to solve absolute value equations. Okay, so let's first talk about, polynomial equations by factoring. All right, so I just kind of want to make a quick little thing up here about all of these. So polynomials, okay. The trick that we want to do is we want to factor and then set each factor equal to 0, okay? That's what we do for polynomials, all right? Now, the next thing that we do for radical equations, okay, to solve radical equations, let's think about radical equations. All right, let's do this. Let's say I've got the square root of x is equal to, I don't know, say 4. Okay, for me to figure this out, what I have to think about is the square root of what number gives me 4. Okay, and that number is going to be 16, but how do we do that algebraically? Now, we got to think about it. The opposite of taking the square root is squaring something. Okay, so what we would do to solve this and get rid of our square root is we would square both sides, and we get x is equal to 16. Okay, so the so a radical equation, the opposite operation is to square, okay? Now, let's talk about rational exponents, okay? I'm going to do that up here. Okay, so a rational exponent is a exponent that's a fraction, okay? Is a fraction. All right, and what we're going to do on that, let's just say that I have, x, and I'm going to do this. X to the 3 halves is equal to 8. Okay, and we'll probably come across this at some point, this exact same problem. But I want to talk about how I solve this. So if I want to undo this, all right, what I would want to do is I would want to raise this to the reciprocal power. So I would raise this to the 2/3 power, and I would do the same thing to this side, raise this to the 2/3 power. And what happens is, I want to show you what happens, okay? If I have x to the 3 halves raised to the 2/3 power, and that's going to equal 8 to the 2/3 power. Okay, what I do with these two numbers is I'm going to multiply them. All right, so this would then give me x to the 3 halves times 2/3. Okay, and that would then give me 8 to the 2/3 power. Okay, so once I do that, I do 3 times 2, so I get x to the 6 over 2 times 3 is 6. Is equal to 8 to the 2/3. Okay, 6 over 6 is 1, so this is just going to be x is equal to 8 to the 2/3 power. Okay, now at this point, what you want to think about is how do you evaluate this? Okay, and what I do is this. I'm going to take this, I'm going to bring this one up over here. If I have x is equal to 8 to the 2/3 power, I'm going to rewrite this as 8 to the 1/3 power raised to the 2nd power. Okay, and I can do that. And what I'm doing here is I'm doing the opposite of multiplying them out. I'm taking a fraction and I'm rewriting it as the product of two numbers. Okay, 1/3 times 2 over 1 would give me 2/3. Okay, and so what I can do is I can evaluate this. Raising something to the 1/3 power is the same thing as me doing the cube root of 8. All right, and that's saying, okay, what number multiplied by itself 3 times gives me 8, and that answer would be 2. Okay, And you can do this a couple different ways. And you want to take a look at my homework solutions when we go through that. But I try to do that first. Try and take the cube root or whatever root it is if I can. All right, and then I square it. Okay, and so then I have 2 squared, so I just have x is equal to 4. All right, so kind of a lengthy problem, but I wanted to go over this in depth and kind of show you why this works, because I'm just going to jump into a lot of these problems and then just go for it. All right. Okay, that's going to be good for this page. I will talk more about, solving equations that are in quadratic form and then absolute value once we get there. So let's just focus on these 3 options for right now, and then, solve those. All right, so let's jump in here. And this is an equation. I want to solve this by factoring, okay? First thing I want to do is I want to set this equal to 0. All right, so I've got 4x to the 4th minus 12x squared is equal to 0. So I want to set everything equal to 0, all right, and then I want to factor it. Okay, so I can factor out a 4x squared out of this, and that's going to leave me with x squared minus 3, okay, and that's going to equal 0. So now these are both factored. Okay, now 3 isn't a perfect square. I can't factor this any further. If you did have a perfect square, then you could factor that further and then continue on. But here's what I got. Okay, I've got this equation here, 4x squared. I'm going to set 4x squared equal to 0. And then I'm going to set x squared minus 3 equal to 0. So if I set 4x squared equal to 0, I'm going to divide by 4 on both sides. 4's divide out. I still get x squared is equal to 0. I take the square root of both sides to solve for x, and I get that x is equal to 0. Okay, so that's one of my answers. Okay, the other answer that I get is right here, x squared minus 3. I'm going to add 3 to both sides. So I'm going to get that x squared is equal to positive 3. Then I'm going to take the square root of both sides, and even though I can't take the square root of 3, I'm going to write it as plus or minus square root of 3. Okay, so those are my answers, all right? And so, you can just leave your answers like that and write out, x is equal to 0, negative square root of 3, positive square root of 3, okay? And that's that. All right, so then let's jump over to the next one. Okay, now this one's a little bit trickier. I'm going to have 4 terms here. Same thing. I'm going to set it equal to 0, okay? And I'm going to do this. I'm going to do 2x cubed plus 3x squared minus 8x minus 12 is equal to 0. Okay, now what I want to do when I've got 4 terms like this is do factor by grouping. All right, however, I have this negative sign here, okay? And the way I get around that is I do this. I do 2x cubed plus 3x squared. I'm going to do plus negative 8x minus 12 equals 0. The reason I do that is because when I group things, I'm not going to screw up my signs, okay? And I have a plus sign in the middle, all right? So now I ask myself, what can I factor out of here? I can factor out an x squared, and I'm left with 2x plus 3. Here, I can factor out a negative 4, all right, and I'm left with 2x plus 3 still, okay, which is nice. Now I can factor out a 2x plus 3, all right, so if I do that, 2x plus 3, I'm left with x squared minus 4, and that's all set equal to 0. Now the cool thing is that I can continue to factor x squared minus 4. So I'm going to get 2x plus 3 times x plus 2 times x minus 2. And that's set equal to 0. So now what I'm going to do is I'm going to set each of these factors equal to 0 and solve. All right, so here's what I've got. I'm going to do 2x plus 3 equals 0. I'm going to do x plus 2 equals 0. And I'm going to do x minus 2 equals 0. All right, so 2x plus 3, I'm going to subtract 3 from both sides, and I'm going to get 2x is equal to negative 3. Divide by 2, I get that x is equal to negative 3 halves. All right, and that's my answer there. Subtract 2 on both sides here, so I'm going to get that x is equal to negative 2. Add 2 to both sides here, I'm going to get that x is equal to positive 2. So my answers for this is that I get negative 3 halves, negative 2, and 2. And those are my answers for x. Okay, so not too terrible, stuff that we're pretty familiar with, but I want to go over here. Okay, these problems get a little tricky, all right, and these are, you know, a little bit more complex than what we had with the, you know, the one that I had above. So the square root of x plus 3 is my radical. I want to isolate this radical. So what I'm going to do is I'm going to first subtract 3 from both sides, okay? And so then I get that the square root of x plus 3 is equal to the quantity x minus 3. Now what I want to do in order for me to get rid of my square root is I need to square both sides, okay? So I'm going to square this side and square this side. So then I'm left with x plus 3, and that's going to equal x minus 3 quantity squared. Now I can multiply this out, all right? And so when I do that, I'm going to get x squared minus 6x plus 9, okay? And that, you know, you can do that by using the box method or FOIL or kind of however you choose, okay? And then I've got x plus 3 over here. Set that equal over there. Now what I want to do, okay, I've got a quadratic and I got a binomial. I'm going to move all these parts over to the other side because I can still, you know, what I want to do, you know, move all these parts to the other side because I want to set this equal to 0 and solve for x, okay? Just like we would if we were given, you know, just this problem right here. All right, so now I'm going to subtract an x, subtract 3, so minus an x, minus 3. And those are going to cancel out. We're going to be left with 0 is equal to x squared minus 7x and then plus 6. Okay? Now, I can solve this quadratic by factoring. And what I'm going to do is I'm going to get x minus 1 times x minus 6. Okay? And that will factor out, that will multiply out to give me x squared minus 7x plus 6. Set each of my factors equal to 0. So x minus 1 equals 0. I'm going to set x minus 6 equal to 0. Add 1 to both sides. I get x is equal to 1. Okay, that's one of them. And then 6. Add 6 to both sides. So I get x is equal to 6. Okay, now these are the solutions that I get algebraically. However, we need to check these. So I'm going to come over here and we're going to check. Okay, so what I'm going to do is I'm going to plug these in. So I'm going to get the square root of, I'm going to plug in 1 plus 3 is equal to 1. Okay, so here's what I've got. Let's see if this works. So 1 plus 3 is 4, so square root of 4 is, that's square root of 4 plus 3 is equal to 1. Square root of 4 is 2. Plus 3 equals 1. I get 5 equals 1. This is false. Okay, so this is when x equals 1. Okay, let's try when x equals 7. Okay, or no, when x equals 6, sorry. So when I plug that in, I got the square root of 6 plus 3 is equal to 6. Let's see if we get the same thing. So here's what we get. I get the square root of 9 plus 3 is equal to 6. Square root of 9 is 3. Plus 3 is equal to 6, so I get 6 is equal to 6. This is true. So here's what I got. All right, when I get two numbers algebraically, okay, one of them works. The other one doesn't, so we got to check. All right, so what I've got here is this. My solution is x is equal to 6. X equals 1 is extraneous. Okay, and an extraneous solution means that, you know, you get it algebraically, but it doesn't work in the original problem. Okay, so a little bit tricky. Okay, but pretty reasonable. All right. Okay, let's do this. Let's try this one. Now this one's hard. Okay, this one may take a while to do, but let's go ahead and do it. I have two radical terms, okay? And what I want to do is isolate one of them, okay? And so what I'm going to do is I'm going to add the square root of x minus 3 to both sides. Okay, these are going to cancel out. And what I'm left with is the square root of x plus 5 is equal to 2 plus the square root of x minus 3. Now, at this point, what I want to do is, once I've isolated one of my radicals, I want to apply the square root. Square both sides, okay? Now, this is where it's going to get a little weird, okay? So on this left side, I'm just left with x plus 5. On the right side, I've got all this, and let me do this over here. Let me use a box for this, because this one kind of sucks, to be honest with you, okay? Okay, so I'm going to do 2 plus the square, or no, is it minus? Yeah, it's minus. Okay, 2 minus the square root of x minus 3. And this is 2 minus the square root of x minus 3. So what I'm going to do is I'm going to combine all these. 2 times 2 is going to give me 4. 2 times negative square root of x minus 3 is going to be negative 2 square root of x minus 3. Here I've got 2 times negative square root of x minus 3. So it's negative 2 square root of x minus 3. And then if I take negative square root of x minus 3 times itself, I'm essentially, it's going to be positive, but I'm going to get rid of the square root, and I'm just going to be left with x minus 3. So if we combine all this stuff together and combine our like terms over here, I'm going to get 4 minus 4 square root of x minus 3 plus x minus 3. Okay, now here's what we've got. Okay, and this really isn't too bad at this point. This problem isn't too bad. Okay, so here's what I got. I'm going to combine our like terms here. I've got a 4 and a minus 3. So that's really just a 1 minus 4 times the square root of x minus 3 plus x, and that's going to equal x plus 5. I'm going to subtract 1 from both sides, and I'm going to subtract an x from both sides. Now these x's cancel out here and here. 1's cancel out. So now that what you're left with is a 4 is equal to negative 4 times the square root of x minus 3. Now I'm going to divide both sides by negative 4 by negative 4. And so those divide out. I get negative 1 is equal to the square root of x minus 3. Okay? At this point, all right, what I want to do is I've re-isolated my radical, okay, which is kind of the idea that I had here. Once I do that, then I can square both sides. Okay? And if I square both sides, then I get this. I get 1 is equal to x minus 3. I'm going to add 3 to both sides, and I get that 4 is equal to x, and that's my answer. Okay, now let's check. Okay, I'm going to do it over here. I don't have much room, sorry. All right, let's check x equals 4. So I get the square root of 4 plus 5 minus the square root of 4 minus 3. The question is do we get 2 as a result? Okay, so, all right, so square root of 4 plus 5, I get the square root of 9 minus the square root of 1. And does that give me 2? Square root of 9 is 3, minus the square root of 1 is 1. Is that going to give me 2? 3 minus 1 is 2, equals 2, and we are good. So our solution is that x is equal to 4. Okay, but in these problems, you do need to check. All right. All right, that one's pretty tricky. All right, I do agree. That one's kind of hard. All right, the next one, I want to solve this equation. Okay, now this is where I have a rational exponent. So what I'm going to do is I'm going to isolate my x value, just like I would in any other case. All right. So I'm going to add 5 to both sides, or add 25 to both sides. Okay. and I am left with 5x to the 3 halves power is equal to 25. I'm going to divide by 5 on both sides. So I get that x to the 3 halves power is equal to 5, okay? Now what I want to do is I want to isolate x. I want to get x by itself. So I'm going to raise this to the reciprocal power, to the 2/3 power. Raise this one to the 2/3 power. And what I'm left with on the left side is x. Okay, I'm not going to go about how I get that. But I'm left with 5 to the 2/3 power, okay? Technically, this could be your answer, all right? That is one way to write it. The other way to write it, okay, would be this, and write it out as, and we could do this a couple different ways. So x equals, let me write it out as 5 to the 1/3 power all squared, okay? Or, okay, there's another way I could do this. I could do x equals 5 squared to the 1/3 power. Kind of depends on how you want to do it, all right? So what I would do, I could write it like this. X is equal to the cube root of 5, the whole thing squared, okay? You could leave your answer like this, all right? Here, I would get x is equal to 25 to the 1/3 power, which is really just the cube root of 25. Technically, I like this one the best. If you saw this problem in like a book or something and you looked in the back of the book, all right, this is what you would see. On my solutions, I will end here. All three of these things mean the same thing. However, the difference is that, it just depends on how you want to write it. Now, this one can't be simplified, all right? I can't take the cube root of 25. I couldn't take the cube root of 5. So, some of these problems, you don't have the ability to, get a real value number from them. However, we got to be able to work with what we got, all right? Okay, let's look at the next one, okay, over here. And I'm going to add 8 to both sides, isolate x to the 2/3. Okay, and I'm left with x to the 2/3 is equal to 4. Okay, now what I'm going to do is raise this to the 3 halves power. Raise this to the 3 halves power. Okay, on the left side I'm left with x, and I get 4 to the 3 halves power. Now this one, you could do this a couple different ways, and let's do it a couple different ways, just so you guys can see how you could go about it. One way, the way that I would do it would be I would take 4 to the 1/2 and then I would cube my number, all right? Or I would take x is equal to 4 cubed and then raise that whole quantity to the 1/2 power. Now I can do, either one works, doesn't matter which one you do, but it depends on how you think about it. Now when I do this, all right, let's think about it. On this left side, I've got 4 to the 1/2. That's really the square root of 4, and then I'm cubing it. Or x is equal to, let me just keep on the left side, okay? And so the square root of 4 is 2, so x would be 2, and then cubed, x would equal 8, okay? And that's my answer. On the right side, what you could do is you could do 4 cubed, and that would give you 64. Okay, 4 times 4 is 16, times 4 again is 64, to raise that to the 1/2. So when I raise that to the 1/2, that's the same thing as taking the square root of 64, and you get that x is equal to 8. All right, so that either one works. Okay, in my opinion, I kind of gravitate towards this side because I prefer to work with smaller numbers, always. Okay, as numbers get bigger, that's when stuff starts to get a little hairy, all right? Same principle, same concept, but, I just want to make sure that that's that, all right? All right, so that's that first page. Let's take a look at the next page. Okay, so let's go take a look at this guy. And here's what I've got. This problem here can be done a number of ways. My method for something like this is called a U-Substitution, all right? U-Substitution. Okay. This problem looks similar to a quadratic. Okay. And so, what I see is I've got, three terms. Okay. And, even though it says x to the fourth and this is x squared, this is still of the form of a quadratic. So here's what I do. I do this thing called a U-substitution. I'm going to let a variable, and I call U, okay, equal x squared. All right? So if U is equal to x squared, I go back in here. All right? I'm going to substitute in my U value, and I get negative 5U, okay? But if I squared U, I would get x to the fourth. So U squared is equal to x to the fourth. If I squared both sides, that's what I'd get. So this over here is U squared. Now, all of a sudden, the difference between this and this is just kind of how I wrote my variables. And what I did is I changed this from something with a fourth degree, or exponent of 4, down to something with an exponent of 2. This I can factor. This factors now to u minus 2 times u minus 3, and I set that equal to 0. The whole point of this is to be able to factor this, okay, and to get down to something that's usable. Now, all right, what I have is now I'm going to resubstitute my values back in, and so I've got this. I've got now that x squared minus 2 times x squared minus 3 is equal to 0. Now I have this factored. All I need to do is set my factors equal to 0 and solve. Okay, so now I've got this. I've got x squared minus 2 equals 0. I've got x squared minus 3 equals 0. Add 2 to both sides. So I get that x squared is equal to 2. Same thing over here. Add 3 to both sides. So I get x squared is equal to 3. Now I can't take the square root of these, but I can. I just can't. It's not going to give me an even number. All right. So what I get is this. Here I get that x is equal to plus or minus the square root of 2. Here I get x is equal to plus or minus the square root of 3. And those, my friends, and you're all my friends, that's my answer. Okay? So pretty cool. All right, now let's look down here to this guy. Same thing. All right, I've got something that looks like a quadratic. So what I want to do is do the same thing. I want to do a U-substitution. All right, so I call it a U-sub. All right, so I'm going to let U equal x to the 1/3. And I always choose the middle term, okay? Because then if I square both sides, okay, that's just going to give me x to the 2/3, all right? So I substitute those values in, all right? And so I'm going to get 3u squared minus 11u minus 4 is equal to 0. All right, now I want to factor this. Let's do this. Let's do the box method. 3u squared minus 4. I'm going to do 3u and u. I'm going to do minus. Okay, here I'm going to put a minus 4 and then a plus 1. All right, so I get 1u and then I get negative 12u. Combine my like terms, and I get negative 11u, which is what we were looking for. Okay, so this is going to factor now to 3u plus 1 times u minus 4, and that's going to equal 0. Now I need to substitute my values back in. So I'm going to plug in x to the 1/3 back in for u. So I get quantity 3x to the 1/3 plus 1 times x to the 1/3 minus 4, and that's going to equal 0. All right, so then what I do is I set each of those equal to 0. So I've got 3x to the 1/3 plus 1 equals 0. And then I've got x to the 1/3. Wait, is that a plus 1? Yeah. X to the 1/3 minus 4 is equal to 0. And I'm going to solve for x. I'm going to subtract 1 from both sides here. And I get 3x to the 1/3 is equal to negative 1. Divide by 3, divide by 3. All right, so then I get x to the 1/3 is equal to negative 1/3. Okay, now what I'm going to do to get rid of x to the 1/3, raise this to the reciprocal power, raise it to the 3/1 power, which is just 3. Okay, and do that to both sides. And when I do that, okay, what's going to happen is I get x on the left side. Here I get negative 1 cubed over 3 cubed, and that's going to give me negative 1 in my numerator and then 27 in my denominator. All right, and that's that. Now over on the other side, I'm going to add 4 to both sides. Okay, so I get that x to the 1/3 is equal to 4. I'm going to cube both sides, just like I did on the left side. And I've got x is now equal to positive 64. These are my solutions. Okay, so, we're kind of putting a lot of stuff together here, but that's the idea. All right, before I talk about solving these problems down here, the absolute value ones, let's quickly talk about absolute value. Okay, so absolute value value is distance from 0. Okay, so and distance is always positive. Okay, so let's say I did this. Let's say, let's just look at a number line here. All right, I'm going to put 0 here. I'm going to put 4 here and negative 4. Now, if I wanted to find the absolute value of 4, okay, I would take the distance from 4 to 0, and that distance is 4. Okay, so the absolute value of 4 is equal to 4. If I wanted to do the absolute value of negative 4, okay, the distance from negative 4 to 0 is going to be 4. Okay, so that distance from negative 4 to 0 is 4. So no matter what goes inside of my absolute value, the result is going to be positive. Okay, therefore, let's ask this question. Okay, let's say I have an equation, absolute value of x is equal to 4. Okay, what are the possible values of x? Okay, and if you look back up here, all right, I did 2 different problems and got the same answer of 4. Okay, so what I could do here is I could say that x is equal to negative 4 or x is equal to positive 4. So it's this step going from an absolute value equation to getting rid of the absolute value, you should get 2 answers. So I'm going to apply this same concept over here to this problem. Okay, so I'm going to solve the absolute value of 2x minus 1 equals 5. Same thing. I'm going to take what's inside the absolute value. I'm going to set it equal to the positive 5, or take what's inside the absolute value and set it equal to the negative 5. And then I'm just going to solve for x. So I'm going to add 1 to both sides, and I get that 2x is equal to 6, divide by 2, divide by 2. I get that x is equal to 3. Okay? Here, I'm going to add 1 to both sides, and I get that 2x is equal to negative 4, divide by 2, divide by 2, and I get that x is equal to negative 2. And these are my solutions. Okay? Same thing down over here. Now, on this one, I don't have an isolated absolute value. That's something I need to do. Okay? First things first, I'm going to add the 20 to both sides. Okay? So that's going to cancel out. I get 4 times the absolute value of 1 minus 2x, and that's going to equal positive 20. I'm going to divide both sides by 4 and by 4. So then I get that the absolute value of 1 minus 2x is equal to 5. Okay? Similar problem. Once I've done this, once I've isolated my absolute value, then I can set up 2 different equations. So I've got 1 minus 2x is equal to 5, or I got 1 minus 2x equals negative 5. All right. I'm going to subtract 1 from both sides, so I get negative 2x is equal to 4. Okay, divide by negative 2. So I get that x is equal to negative 2. Okay, here I'm going to subtract 1 from both sides. So I get negative 2x is equal to negative 6. Divide by negative 2. Divide by negative 2. And I get that x is equal to positive 3. Did I get the same thing? All right, you're not always going to get the same answer, but that's the idea. All right, so that's what we've got for those, and we'll see you in a bit. Thanks a lot. Bye.